Okay, so AI, it's everywhere. I mean, not like Terminator style yet, but it's in those movie recommendations that are scary accurate. The spam filter that's single-handedly saving your inbox, even those filters that make our selfies, let's just say pop. But all that AI magic, it doesn't run on good vibes, unfortunately. It takes power, like massive data centers, huge energy bills, not exactly eco-friendly. And that is where this deep dive comes in. We're talking neuromorphic computing and potentially the solution to AI's energy problem. We're diving into some seriously cool research here, straight from the Indian Institute of Science, IISc for short. And guys, this is the big leagues, like published in Nature big, the kind of breakthrough that could change, well, everything. Get this. They've developed a system that might make AI way more efficient, maybe even powerful enough to run those complex algorithms on something as small as your phone. Imagine the possibilities. But got to start with the basics. Why is this research such a big deal? We need to understand the limits of computers as we know them, those good old zeros and ones. It's like trying to write, I don't know, a symphony, but you've only got two notes.
Yeah, it's a system that's gotten us this far, sure, but it's limited, especially with the crazy amounts of data AI needs. Take large language models, LLMs, those things powering stuff like ChatGPT. Training those demands so much energy, it's a huge roadblock, not to mention what it does to the environment.
Okay, so this new research, they found a way around that zeros and ones thing, like ditched it completely.
Kinda. What they did was look at molecules. Imagine a molecular film, okay? Where molecules, ions, they're constantly moving, interacting, creating tons of potential states, way more than just on or off. The challenge has always been, how do we control that? How do we even read what those molecules are doing to use it for information?
So it's like these molecules have been having a conversation this whole time in a language we just couldn't decipher, and they finally figured out how to listen in.
Exactly. The ISC team, they found a way to guide those molecular interactions using these super precise, super fast voltage pulses, like nanoseconds fast, a billionth of a second. By tweaking those pulses, they can write information onto the molecular film, arranging the molecules in specific ways, and then to read that info, they just observe how those molecules react to the next pulse.
Hold on, so they're basically using these tiny, tiny zaps of electricity to, I don't know, choreograph a molecular ballet, and each dance move is a piece of data.
That's a great way to put it. It's like they made a molecular diary.
Yeah.
Each unique configuration of molecules, that's a different entry. And get this, they've accessed something like 16,500 of these states.
16,500, that's mind-blowing, going from our two-note symphony to a whole orchestra, right?
Exactly. And what's even cooler is, this isn't just theory. They proved it works. They used it to recreate a super complex image. The pillars of creation. You know, the one from the James Webb Space Telescope.
Wait, the one with those like incredible columns of gas and dust where stars are forming? I remember reading it took a supercomputer to even process all that data from the telescope.
Exactly, a supercomputer. But the ISC team, they recreated that same image. Incredible detail.
No way, using their molecular diary thing. That's nuts.
And they did it, get this, with a tabletop setup. Like they basically took a supercomputer, crammed its power into this molecular film.
Okay, see, that's what I call show, don't tell. They recreated the pillars of creation with molecules. It's like they cracked the secret code, but instead of buried treasure, it's like a whole new era of computers.
It really does change things. And I'm not just saying AI gets faster or uses less energy. This could democratize the whole thing, make AI development possible for like any institution, any researcher, even just people who don't have those massive data centers just lying around.
So instead of needing a whole room full of servers to run some cutting-edge AI, you could do it on something that fits in your pocket. That's wild.
Exactly. Think about like medicine. Personalized medicine could go to a whole new level.
Yeah.
Algorithms analyzing your genes, your medical history, creating treatments just for you. And it's all happening on something the size of a smartphone.
That would be incredible. What about education? There's been talk of AI tutors, but could this actually make them, like, really work?
Oh, absolutely. With that processing power so accessible, AI tutors that adapt to how each student learns in real time, figure out where they're struggling, personalize the lesson right there.
Yeah.
Everyone gets a custom education.
It's amazing to think about, especially for, people who don't have access to the best resources right now. But hold on, back to the tech itself for a sec. This molecular film,
Yeah.
how do they even make it? Is this something you can just, like, whip up in a lab?
Well, not exactly baking a cake, but it shows how clever this research team is. They're using quantum materials. They have these unique properties perfect for this kind of thing. And the really cool part is, these materials, we can make them in the lab. which means we can manufacture them on a large scale.
So not only is the tech groundbreaking, it could be widely available too. That's a powerful combo. What's next for the ISC team then?
They're already working on a neuromorphic chip based on all this.
A chip that runs on molecules, not zeros and ones. That sounds like something out of sci-fi, honestly.
Right. And the best part is they're aiming for it to be completely indigenous.
Indigenous.
Designed, developed, made, all in India. This isn't just a science thing, you know?
Yeah.
It shows how India is becoming a leader in tech, a global leader.
Wow. Okay, that's huge. We're not just talking about a new ship here. We're talking about, like, shifting the whole landscape of tech.
Exactly. And it all started with a simple question. What if we rethought computing at its core? What other limits can we break if we just challenge those assumptions we have about technology?
It's like that saying, the only limit is our imagination. But in this case, they're not just imagining it, they're actually doing it. I mean, seriously, it's kind of mind-blowing when you think about it. We started with, how do we make AI use less power? And now we're talking personalized medicine, on your phone, all thanks to, like, a film of molecules. This is how science fiction turns into, well, just science.
It really is exciting. And the coolest part, I think, is that it came from questioning those really basic assumptions about how computers even work. Makes you wonder what other problems we think are impossible. Maybe they're not. We just need to ditch the old rules.
Totally. It's like we're standing on the edge of something brand new. If we can rethink something as fundamental as computing, what else are we holding on to that's actually holding us back? You know, what breakthroughs are just waiting to happen if we, like, ditch the zeros and ones, think outside the, I don't know, the motherboard?
That's a great question. And this research, it's proof that the future of tech, it's not just about making things a little faster or a little sleeker. It's about coming up with totally new ideas, going where no one's gone before. Who knows what's out there when we start playing with the really small stuff?
So to everyone listening, whether you're a tech whiz or you think AI is going to take over the world or you just like a good science story, here's something to think about. What else seems impossible right now that might not be? What can we unlock when we start speaking the language of molecules? That's all the time we have for today's deep dive into the incredible world of neuromorphic computing. But this is really just the start. We cannot wait to see where this technology goes, what other amazing discoveries are right around the corner. Until then, keep those imaginations going, and hey, maybe you'll be the one to break the next big tech barrier.